Hello everybody, welcome into another lesson. So today we are going to talk about adding and subtracting polynomials. But first, let's get into what polynomials are exactly. So here we have what's called a monomial. If it's just got one term, and it could be a constant. If I just had the 2 without the x squared, that would be a monomial. If I just had the x squared without the 2, that'd be a monomial. Or if I multiply them together, got 2x squared, that's a monomial. It's just got one term. And then if I had two terms, such as 2x squared minus 9x, two terms, that's a binomial. Then if I have three terms, 2x squared minus 9x plus 7, for example, that's a trinomial. All of these are types of polynomials, which are nothing more than the sum of monomials together. That's all a polynomial is. So what you have to do now, we want to find the degree of a term. The degree is the power. So in this monomial 2x squared, the degree is 2. So the degree would be 2 in this monomial because it's raised to the second power. Now, if you're looking to take the total, the degree of the whole polynomial, what you have to do is take the highest degree in the equation. So for example, in this trinomial 2x squared minus 9x plus 7, the trinomial, the highest degree is 2, so this trinomial is of degree 2. It's of the second degree because the highest power is to the second power. So there is that. Now, let's also say you have an expression like this. What if I had an expression like this, x squared y? What would be the degree of that monomial? If you have more than one variable, what you're going to do is you're going to take the sum of the degrees of each variable. So the x term has a degree of 2, the y term has a degree of 1. So 2 plus 1 is 3. This monomial is of degree 3. It's a third degree monomial because you have x to the second power, y to the first power, so it's a third degree monomial. Let's say I had x to the fifth, y to the seventh. So to find the degree of this monomial, I'm going to add the powers together. I have the fifth power plus the seventh power. This would be a degree 12 monomial because the fifth power plus the seventh power equals the 12th power. So that'd be a 12th degree monomial. Let's say I had x, y squared, z cubed. Let's say I had a monomial like that. Again, if I want to find the degree, I'm going to add the sum of the powers. X is to the first, y is to the second, so 1 plus 2 is 3, plus a z to the third, that'd be 6. So this monomial has a degree of 6. So that's how you determine the degree of monomials. Now, let's say let's say I created a nice trinomial here. I want to find the degree of the entire trinomial. Well, let's take the degree of each term of the trinomial. We've already established this one's degree 6 for this this single term is degree 6. This term here, the x squared y, the degree would be 2 plus 1, that'd be 3. That's got degree 3. And then this y squared z, that's 2 plus 1, that'd also be degree 3. So the highest power is in the first term, the xy squared z cubed with degree 6. Therefore, this is a sixth degree trinomial. The overall degree would be 6 because that's the highest power you have. That's the highest sum of the powers you have. Okay. So now we know about degrees of polynomials and monomials and so on. Now it's time to get into what we really came for, adding them together. So let's say you have something like 2x minus 5 minus x minus 2. Well, in something as simple as this, you have just a variable and a constant. You have the same variable x and then a constant. So what you're going to do is take your 2x, of course, start with your 2x, try to arrange it in order. Then you have minus, you're going to distribute that minus sign into this set of parentheses. So minus x, you'll have 2x minus x. Then you have a minus 5. Then you have minus minus 2, which would actually be plus 2. So what I did is I took that minus sign, I distributed it into the parentheses, so you get 2x minus x. Then you have the minus 5, and then minus minus 2 is actually plus 2. So whenever you add or subtract polynomials, it's basically simplifying. It's basically just simplifying the equation, which we've been doing all along. This is just a fancier way of doing it. But now if we go through, we do 2x minus x, you'll get x. Negative 5 plus 2 is negative 3, so you would get x minus 3 for your final result. I got more examples. Alright, let's see. We got 3m plus 5, that quantity, minus the quantity of negative 2m plus 3. Well, again, we want to find like terms. We want to group the like terms together between these two quantities. So the 3m, and then we distribute that minus, so minus minus 2m is plus 2m. So first start out, group your like terms together. Group your like terms together. Start with your variable terms and then deal with your constants. We have a plus 5. Then you have minus 3. Well, that'd be just that, minus 3. We simplify this, 3m plus 2m, that's 5m. Then we have 5 minus 3, that'd be plus 2. So the answer you should get for this would be 5m plus 2. That's exactly what you would get when you simplify. Alright, time to take it up a notch. Let's see here. We got 2x minus 5y plus 2, that quantity plus the quantity of 5x plus 6y minus 7. Okay? So So we got these two quantities. Again, group your like terms together. Start with the x's, so you have 2x. Distribute that plus sign, so you have plus 5x. Alright, that's it for the x terms. Now you have a minus 5y plus 6y. Alright, you've dealt with your y's. Now you just got constants. So you got plus 2, then you have minus 7. So now we're going to go through and simplify this. 2x plus 5x, well that's 7x. Negative 5y plus 6y, that's plus 1y, or just plus y. Then you got positive 2 minus 7, that'd be negative 5. So the answer you get should be 7x plus y minus 5. That's exactly what you should get. All right. Let's see. Let's do 2p minus 7q minus 4, that quantity plus the quantity of 3p plus 2q minus 1. Alright. So again, start with grouping your like terms together. You have 2p plus 3p. So you've dealt with your p's. There's no more p terms. Now you have minus 7q plus 2q. Then you have minus 4 minus 1. Alright, so now we'll go through, we will simplify this. You'll have 2p plus 3p, that'd be 5p. Now you have minus 7q plus 2q, that'd be minus 5q. Then you have minus 4 minus 1, that'd be minus 5. So the answer you should get for this would be 5p minus 5q minus 5, once you simplify. Alright, take it up another notch here. Let's say we got something like this. We got 3n to the second power plus 5n minus 6 plus the quantity of negative n squared minus 3n plus 3. Alright. So, up until now, from pre-algebra up till now, we've only dealt with variables to the first power. That's all we've dealt with so far, variables to the first power. Well, now we got variables to the second power, and pretty soon we're going to have higher. So the goal is still the same. You want to get the like terms together. And even if you have the same variable, I cannot add 3n squared and 5n. That doesn't work. Why? Because the like terms have to have the same degree. They must have the same degree. So for example, 3n squared, then I have plus the negative n squared, which would be minus n squared. These are like terms. They have to have the same degree. Then now you've dealt with the n squared, so now you have plus 5n. Then you have minus 3n. Okay, so the n's to the first power, those are like terms. So even if you have the same variable but different powers of it, those are considered different terms, not like terms. So in a sense, it's almost like if you have the same variable to another power, you almost treat it as another variable, if that makes sense. That's almost really what you're going to do. Now we got the constant, minus 6. Then we have plus 3. So we'll go through, add all this up. We have 3n squared minus n squared. We just take the coefficients still like you would for like terms and subtract. The coefficients, of course, 3 and 1. 3 minus 1, that's 2, so you'll get 2n squared. Then you have plus 5n minus 3n, that'd be plus 2n. Then you have negative 6 plus 3, that'd be negative 3. So the answer you should get for this problem, once it's simplified, should be 2n squared plus 2n minus 3. You still go through, add, subtract the coefficients like we always have. The constant on each term is called the coefficient. I should have specified that earlier. I'm sorry I didn't do that, but yeah. The constant term, the 2, that's the coefficient on the term. And I got more examples. Alright, how about y squared plus 6y minus 5, that whole quantity plus the quantity of negative y squared minus 3y minus 1. Okay? So once again, you have the y variable, that's true, but you got a y to the second power terms and you got y to the first power terms. So again, in order for them to be like terms, they have to have the same power. So the y squared, and then you have plus minus y squared, which would be minus y squared. Those would be like terms. We've dealt with the y squared. Now we have plus 6y minus 3y. Now we have minus 5 minus 1. Okay? We've grouped the like terms together, which always helps you in these problems. So now you have y squared minus y squared. That's 0. Y squared's gone. Bye-bye. Now we have 6y minus 3y. That'd be 3y. Then you have minus 5 minus 1, that'd be minus 6. So the answer you should get for this should be 3y minus 6, because the y squared's history. Because each coefficient was 1, you have 1 minus 1, that's 0. So, yeah. Now, some of these, especially because we're getting into higher degrees, can look intimidating, but it's really not. You just treat each degree as its own variable, if that makes sense. Alright, let's see here. Let's do one more like this, and then I'm going to move on to some other types. So we have 3x squared minus 4x minus 2 minus the quantity of minus x squared minus 4x plus 7. Okay. So we clearly see we have x squareds and x to the first and constants. The x squared terms, again, those will be considered like terms. So you'll have the 3x squared, minus x squared, that's actually plus x squared. We've dealt with the x squareds. Now we have minus 4x, minus 4x, well, that's going to be plus 4x. You've dealt with the x's. Now you have minus 2, minus 7. So now we can go through, since we've collected the like terms together, we can simplify this. So 3x squared plus x squared, add the coefficients, 3 plus 1, you'll get 4x squared. Now minus 4x plus 4x, that's 0. Bye-bye to the x to the first. Now you just have minus 2 minus 7, that'd be minus 9. So the answer you should get for this would be 4x squared minus 9. Alright, for the final challenge here, I'm going to take it up yet another notch. Let's say you have u to the third minus 3u squared v plus 2uv squared. All that plus the quantity of 3u squared v minus 2uv squared minus v to the third. Okay. So, we still want to collect like terms. That hasn't changed. Now, whenever you have more than one variable on a monomial, the degree of each variable must be arranged exactly the same way in order to have a like term. So I can't add negative 3u squared v and 2uv squared. Though overall the degree of the monomial is the same, the degree of each variable on that monomial has to be the same. Otherwise it's not a like term. So let me illustrate here. Let's look for u cubed, u to the third. We have u to the third. Do you see any other u to the thirds? You do not. We're done with u to the third. Now we have minus 3u squared v. Do we have any other u squared v terms? We do. We have a plus 3u squared v. Alright, so we've collected. These two are like terms because each variable on the monomial is the exact same. Now let's do plus 2u v squared. Then you have the minus 2u v squared. That's the same. They're like terms because the u and the v both have the exact same power. They have to have the exact same power. Alright, we've done those. All that's left is minus v cubed, and I don't see any other v cubed terms. I see no others. So now we're going to go ahead and simplify this. U cubed, there's no other like terms with u cubed, so that stays. Now we have minus 3u squared v plus positive 3u squared v. That goes to 0. Bye-bye to that. Then we have positive 2uv squared minus 2uv squared. That goes to 0. Bye-bye. All we have is minus v cubed. That's all that's left. So the answer you should get for this one would be u cubed minus v cubed. So, once again, to recap, of course you have to have the same power in order to have like terms, but if you have a monomial term that has more than one variable, in order to have a like term, the other term must have the power of each variable arranged in exactly the same way. If it's not a like term. That's why negative 3u squared v and 2uv squared are not like terms, because one, has u to the second power and v to the first, the other has u to the first, v to the second. Those are not like terms. So it's important to know that. And I got more examples here. Alright, so I got 2x squared y minus 3xy squared minus y to the third, that whole quantity plus the quantity of 2x squared y minus xy squared. Okay? So let's go ahead and start with a 2x squared y. Do we have any other terms that have the variables x squared y exactly like that? We actually do. We have another 2x squared y. We can add another 2x squared y. Those are like terms between here and here. Alright, now we've dealt with the x squared y terms. Now how about the xy squared? We have minus 3xy squared. Do we have any other terms that have xy squared? We do. We have minus xy squared. Alright, so now we've dealt with the xy squared terms. There's no more. All that's left is minus y to the third. There's no other y to the third term, so that's all we can do for that. So as you can see, I have arranged the like terms. I've arranged the x squared y's with the x squared y's. I've arranged the xy squareds with the xy squareds, and the y cubed kind of hangs out on its own because that's the only term for it. So now we're going to add the coefficients of the like terms. So 2x squared y plus 2x squared y, well, that'll give you 4x squared y. Now you have minus 3xy squared minus xy squared, the coefficient minus 3 and minus 1, that'd be minus 4xy squared. Then you just got minus y cubed. So the answer you should get for this should be 4x squared y minus 4xy squared minus y cubed. And I'll do some more examples here. I think we'll do two more. We'll do two more, then we'll call it a lesson. Alright, let's see here. We have 3a to the third minus 2ab squared. That quantity minus the quantity of a to the third minus 4ab squared minus b to the third. Alright. So once again, we've been given our sum or difference, in this case a difference of two sets of polynomials. We want to collect our like terms. Let's start with the a cubed term. We have 3a cubed minus, we have any other a cubed terms? We do. We have minus a cubed. Alright. I don't see any other a to the third, so we've dealt with the a to the thirds. Now let's do minus 2ab to the second power. Do we have any other ab to the second power terms? We do. We have minus 4ab to the second power, which is actually plus 4ab to the second power. I don't see any other ab to the second power terms, so that deals with that. Now all we have left is minus b to the third. That'd be plus b to the third. So now we can go through and simplify all this. So we have 3a to the third minus a to the third. So 3 minus 1, that's 2. You would get 2a to the third. Now you have minus 2ab to the second power plus 4ab to the second power. That gives you plus 2ab to the second power. And then you just have plus b cubed hanging out all by itself. So the answer you should get for the simplified form here is 2a to the third power plus 2ab to the second power plus b to the third. And yes, I am going to do one more example, and that'll be the lesson. Come on, there we go. Alright, we have 2p to the second power q minus 3pq to the second power plus q to the third power. That whole quantity minus the quantity of negative p to the second power q plus q to the third. Alright. So let's go for our like terms here. Let's start with our p squared q term. So we have 2p squared q. Do we see any other p squared q terms? We do. We have minus p squared q, which is actually plus p squared q. Alright, I don't see any other p squared q terms. Now, how about the pq squared? We see minus 3pq squared. Do we see any other pq squared terms? We do not. Now we just have the q cubed term. So we have q cubed minus q cubed. So we have arranged the like terms now together. So that makes our life a lot easier when we go to simplify this. So we add the coefficients of 2p squared q plus p squared q. That'll give you 3p squared q. Now you have just minus 3pq squared. Then you have q cubed minus q cubed. That goes to 0. That's done. So the answer you should get for this is 3p squared q minus 3pq squared. So overall, let's work backwards here, okay? When you're adding or subtracting two sets of polynomials that have more than one variable, your like terms, they can only be like terms if you have more than one variable on each monomial, if the powers are arranged in the exact same way. So p squared q only goes with p squared q. P squared q would not go with pq squared. It doesn't work. So, and then in general, if you have the same variable in a monomial, or in a polynomial rather, you're trying to add or subtract two polynomials to collect like terms, you have to have the same degree. They have to be to the same degree to be like terms. So if I had 3x squared plus 2x, those are not like terms because they're not to the same power. So that's really all there is to adding and subtracting polynomials, just collecting your like terms and simplifying. The next lesson, in my opinion, is going to be a little bit easier. It's going to be about multiplying monomials. So I hope everybody has a good night. Take care.